Hello and good morning. Please, can you hear me?
Yes, sir. I can hear you.
Okay, thank you. Welcome. Today's class, we'll be looking at this technique of proving statements mathematically. Last week I showed you that we actually looking at we looked at various methods of proof, and we were able to look at truth table, logical connectives, logical equivalence. And then we saw what tautology, contradiction, contingencies, and then how to prove valid arguments. The last part of that type of proof is what is a predicate statement, and how these proves that these statements are proved, whether the statements are true or not true. So this morning and early afternoon, we want to look at what we call a statement that is a predicate statement, and then be able to identify when you are given a problem, what is the best approach to be able to prove those statements? You should know at least one method. There are quite a number of them, but today I will introduce the direct, indirect, and then contradictory method. Indirect is the same as contrapositive, and then we have contradiction as well. So we see how far we can go with this. And then the Socrates room name has already been given. Okay, so please take note of that. And if you have any questions from what we've done so far, let me know. You can either ask them or type them in the chat room. I'll be looking at them as we go on. Okay, so we'll begin with what we call statements that are known as predicate. So I will start from the PowerPoint and then we will take more examples in the Excel document. Okay, so you should have on your screen the PowerPoint. So there's the outline. Last semester, we looked at induction. So we are not going to look at that this time around, but we'll look at predicate statements, the first part. And then the second part, we'll look at the methods of proof, direct, indirect, and then contradictory. And we'll take one or two exams from there. Okay, so let's recap what we've done so far with respect to logic. So here, we learned from our logical statements that a statement is said to be a proposition if and only if that statement happens to be either true or false. I hope you remember this rule. A statement is a propositional statement if and only if that statement is either true or false. Then we came across statements that involve variables. Now, this particular type of statement, we said we cannot determine whether it's true or false because we don't know whether the variables have been defined or which domain they are coming from. So what we are going to do today is introduce a type of statement that involves variables. And that gives us our first definition. A predicate statement is any statement that contains a variable. Any statement that contains a variable. So when you are given a statement and then you are able to identify the variable in there, then that statement is satisfies or it suffices to say that that statement is a predicate statement. Okay, so when we identify these statements, what we do is that to know whether those statements are either true or false, for us to know whether they are true or they are not true, is to use what we call quantifiers. Now, what are quantifiers? Quantifiers are basically words that are used, but when they are used, they can be converted into symbols. Now, there are two types of quantifiers. One is called the existential quantifier. Now, this essential quantifier, what it does is that it will pick specific members in the domain, specific. Say there is, or there is someone, or a person. Now, those of you who are online right now, you are 58. But if I assume that all BIT weekend distance learning students, all of you bank with, let's say, Fidelity, all of you bank with Fidelity, you can say that that statement, all weekend students, distance learning students, banking with Fidelity Bank, it's not true. All I need to do is to find one person among you who doesn't bank with that bank, and that statement is not true. So I'm using what I call the existential quantifier. I'm picking few people or a person from that group. But if I pick all of you, and that makes that statement not to be true. But if I pick just a few, let's say that there is one student in distance learning class, VIT weekend, that banks with Fidelity, that statement may be possibly be true. Okay, so I'm using the word the exist, that is existential. And then when I use the word or, then I'm using what I call the universal. So these two words that you have here, the existential and then the universal, they will force the statement to either be true or not true. Okay, so we are going to interrogate this assertion very well before we will leave this topic. I want to make sure everybody is following. So I'm going to give four simple examples, and please let me know what you think about it. These are the four examples. All triangles have the sum of their angles equal to 180. All triangles have the sum of their angles equal to 180. Now, the first thing I need you to tell me in this statement is that what is my variable statement here? What's my variable word here? Which word here is the variable?
All.
No, all is a quantifier. All is a quantifier. A variable is a word that has different types. When you say X is a variable, X can be 1, can be 2, can be 3. So what word here is, thank you, triangle. So triangle is my variable. Good. Now, let's go to the next statement. The next statement, I'm saying that all cats have tails. All cats have tails. Now, what is my variable statement here? All cats have tails.
Oh,
yes.
cat.
It's cat. Yes, cat. Cat is my variable here. Now, there is an integer satisfying x squared is equal to 2. Now, what is my variable here?
Integer.
Integer. Exactly. Integer. Good. Now, then there is a prime number which is not odd. There's the prime number which is not odd. What is the variable here?
Prime number.
Too much prime.
That's a prime number.
Okay, so we have correctly and graciously identified all the variables here. Now, what we are supposed to do now is to identify or check whether these statements are true or not true. Now, I want to interrogate this very well. So I'm going to use the Excel document to be able to explain what we've just done. So if you are given a problem like this, the first thing you do is to identify the variable, which we have done. Now, the next thing is to identify the quantifier. Remember, I told you that there are two types of quantifier. The universal quantifier, which uses the symbol for all, like an A written upside down. And then there's the existential quantifier, which uses the word there is. Okay? And the symbol is like an E written backwards, capital E written backwards. So if you take the questions that were given in the PowerPoint, I have brought them here. The first words are the quantifiers. So all is a universal quantifier because it's coming from the word for all. The second one too uses all. The third and the fourth, it uses there is. So we've been able to identify the quantifiers for these questions. Now, for us to answer this, we must first of all translate these phrases, English phrases, into symbolic form like we did in logic. Okay, remember the question. Either the moon is made of green cheese or Nana Consa there are 3 wives. That whole thing became some P and Q or not R, something like that. We want to translate all these phrases into symbolic form using the correct quantifiers. So let me show you how to do that. So the first one is all triangles have their sum of angles equal to 180. And you correctly identify the word triangle as your variable. So here, triangle is my variable. And why is that so? Because there are 4 types of triangles. We know that we have the right angle triangle, we have the isosceles triangle, we have the scalene, and then I think we have the equilateral. Okay, at least there are 4 types. So it means that if we say all triangle, then we are referring to all these 4 types. Now, then we will rewrite the statement where the word triangle is now will be replaced by the variable x, because that is a variable name. And from that variable x to the end of the statement, I'll represent it as a capital letter into brackets, the variable x. So I'm using T of x to represent the statement involving the variable triangle. So from triangle all the way up to degrees will be called T of x. So this will be x representing triangle have the sum of its angle equal to 180 degrees. So if I'm able to do that, I will no more be reading this whole thing the way it is. I'll just will pick the quantifier. All triangle will mean using the inversor quantifier. I'll be using the inversor quantifier this for all, so representing that. And then for triangle, I'll use x. So this one is going to be for all x, okay? And then that triangle having the sum of angles equal to 180 will be capital T into bracket x. So that will be the statement, all triangles have the sum of angles equal to 180. I've translated that whole problem into symbolic form. Okay, so that is what you have here. Now, the question is this statement true or is it false? Is it true that triangles have their angles equal to 180? Is it true or is it false?
False.
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 Oh, are you sure? Do you remember equilateral triangle?
Yes, sir.
Equilateral triangle, what is the angles inside?
The sum of interior angle is 180.
Yes, so why are you saying it's false? Or because they didn't say interior angles? It's actually referring to interior angles. Right angle triangle, you see that one of the angles will be 90, and sometimes the others will be 45, 45. Or it could be 30, 60, or it could be 20, whatever. But if it's right angle, there will be a 90. The other 2 angles will add up to 180. Isosceles to the same thing. Scaling to the same thing. Equilateral, we know 60, 60, 60. So it is a property of triangle. If you type properties of triangle, you see that one of the things that you will read about is that their internal angles add up to 180. So this statement, it must be true. It is true because it's a property of triangles. It's only triangles that have that. All the other figures, they don't have this property. Okay, so that statement will be true. Okay,
Master,
now
how will you know this is referring to interior angles?
okay, so that's the point I'm making, that maybe because they did not say that the sum of interior angles add up to 180. If they are not interior, they will be exterior. Now, definitely try if you take a triangle, the exterior angles, you can't even, unless you elongate their what do you call vertices. But obviously, if they talk about angles or triangles, it must be interior angles. It cannot be exterior. So maybe the qualification that didn't come, that's why you were thinking like that. But anytime they mention angles of a triangle, it must be the internal angles. It cannot be angles outside, unless they've drawn it on a plane and it is touching a line and things like that. Okay, so please take it from me that if it is given to you, the question is given to you like that, and it is not a figure that is also attached to another figure, it's standing alone, it's a triangle, then the angles they are talking about will be internal angle. Okay, but please, as you go on, you understand or you appreciate where I'm going with all this. Some of the questions you will see that your knowledge may not, your information you have may not be, what is the word we can borrow? It doesn't cover to the extent of what the question is asking, but it's because we are trying to explain the concept of predicate statement and how to prove them. So please bear with me when I give you questions or we see examples that you are not familiar with. It's not to expose your knowledge or ignorance. It is just to make you understand what goes into proving these things. The next question will explain what I'm trying to say. Look at the second one. All cats are tails. All cats are tails. Now, you correctly said that cats is our variable. So if I replace cat with X, then that statement, cats have tails, will be replaced by X have tails. X having tails. Okay, so now when I use the word all cats will be represented by, for all, borrow this equation. So this will be for all X, but this time not T, I'm using C of X. So for all cats, that means for all X. And that cat have a tail is C of X. Now, what type of cats do you know? Now we are now going to interrogate this to find out whether it's true or false. What are the family of cats that you are familiar with or you know?
Leopards.
Yes, I didn't hear that.
Leopards.
Yes, leopard.
Jaguar.
Yes, jaguar.
Tiger.
And then you have the others, puma, cheetah, lion.
Bobcat.
Okay. So all these are cats. Puma, lynx, LYNX. They are all family of cats. Now the question is, all these cats that I've listed here in the family of cats, including your domestic cat, your pussy cat, all these cats, do they all have tails? Is it true or false?
True.
False.
Okay. So
False.
somebody said true. Somebody said true. Somebody said false. Okay. Now those who are saying true, what when I ask you to prove that, when those are saying true, what will you say? How will you prove that all cats are tails? What will be your answer?
All the types listed have tails.
Okay, good. So you are basing your information on what you are familiar with. Okay. Now the gentleman who said no, what will be your reason for saying no? No. Why? Why is it no? Why is it false?
Because not all cats have tails.
Okay, yes, that's assertion. That is the position you've taken. But what is your proof?
Maybe you have seen a cat without a tail before.
Okay, I won't argue with you. Okay, so the way to prove these things, if you have time and it is not an exam or it's an assignment, is to, because the quantifier is all, then you must go to Google and find out, are there cats without tails? If you're able to do that, you will see that there's a cat called Max, M-A-N-X.
Yes, sir.
There's a cat called Max. This Max cat, by virtue of how it is formed, if you go looking for more of it, they don't have tails.
Yes, sir. Yes, sir.
Okay, so in our part of our world, we don't have these type of cats. We don't have these type of tailless cats in Ghana or in, let's say, the sub-region itself. So you may assume that this statement is true. Okay, so like I was trying to explain to you in a few minutes ago when we're looking at the triangle, the whole concept about what we are trying to learn is that before you say that something is true, or before you say that something is false, you must be able to prove for the whole domain where your domain must be your knowledge of that domain. If you are not familiar with the knowledge of the domain, then restrict your truth value to the domain you are familiar with. Okay, obviously, I will not ask you a question that will question or will virtually make you use this type of argument. But I'm saying that in explaining why this statement is false, because there is a max cut that does not have a tail. And I'm saying that if you don't know that, then you will restrict your answer. If you say that a statement is true, for example, then you say that my domain, let's say, can be all cut from Africa, for example. Okay. And even Africa, are you even sure of all the parts of Africa? Okay, so if it is a research you are doing, then when the question says universal, it picks a universal quantifier, or then go and look whether there is a cut without a tail before you say that it is true. If you are not able to prove that, then it better you choose answers that will restrict your domain to your knowledge of existence where you are familiar with. Okay, so that is how we are able to prove these statements. You just don't say that a statement is true and get away with it. You say it's true, then give reasons. You say it's false and give reasons. Okay. At the end, remind me, I'm going to show you how the types of questions I ask under this topic. Obviously, there is a restriction as to how far I can go with this, because in an exam room, you don't have the internet to check these things. So there must be a format of questions that is allowed so that we don't deal with controversies. Okay, now let's take the next one. There is an integer satisfying x squared is equal to 2. There is an integer satisfying the equation x squared is equal to 2. Now, you correctly identify the variable as integer. So your variable is integer. Now, so integer x satisfying this. So you will just say x satisfying the equation x squared is equal to 2. Equation x squared is equal to 2. Okay, so that is your statement. Now, we want to find out, is this statement true or is it false? Is there an integer that when you square, it will give you 2? Is it true or is it false?
False.
It's false. Okay. Okay, so first of all, we have to rewrite this as a symbolic form. So just like I did for the other one, this one there is. So I will be borrowing the existential quantifier. So not for all, I'll be using there exists. I hope I have it somewhere here. Okay, so there exists x, and then instead of c of x, now it will be I of x. Okay, so we are saying this statement is false. And the reason why you are saying it's false is because of what? Why is it false? How do you prove that this statement is false? What do you do? Now, unlike the first two examples that are English phrases, this one is an equation. So the best way is to solve the equation. Now, if you solve for x, if you make x the subject in this equation, you are going to get x is equal to square root of 2. So that's the square root of 2 here. Now, square root of 2, when you evaluate it on the calculator in the Excel, I've written 2 raised to the power half. That's square root of 2. It gives me 1.41. And the more I open my Excel, the more it gives me more numbers. 41, 42, 135, on and on and on. It's a type of number that does not end, and the numbers doesn't repeat. Okay, so what type of number is square root of 2? That will be your proof. What type of number is square root of 2? Obviously, it's not an integer, isn't it? It's not a whole number. Integers are whole numbers. So what type of number is square root of 2? Yes, a decimal, but it has a family name. What type of decimal? Irrational. Okay, so you say it is false because square root of 2 is not an integer, but an irrational number. That is why this statement is false. Okay, so those who are joining us after, I started with 30, going to 50, now we are 84. So I am sure some of you missed the beginning. We are looking at statements that involves variables. And the variables are identified by the word that is in the question. The first example, we said all triangles have the sum of angles equal to 180. We said triangle is a variable. All cats have tails. We said the word cat is a variable because there are different types of cats. Triangle, there are different types of triangle. Here, there is an integer satisfying the equation x squared is equal to 2. The variable here is integer because there are different numbers that are integers. And we are proving that they are either true or false. How do we prove them? The first word that starts the statement identifies them as whether we are using what we call a universal quantifier when they use the word or we are using the existential quantifier. There's this. So these two symbols here will now translate the word or into using the symbol as this. And then when they use the word there is, we'll use the symbol. And these two symbols or two words help us to know whether the statement is true for all the domain or for some members in the domain. Please, that is what we are looking at. I hope I have updated you. Now let's look at the fourth example. There is a prime number which is not odd. And then you correctly identify the variable as prime number. Okay, so we are going to replace prime number with x. And then the whole statement from prime number to the end will be written as x here, which is not odd. Okay, so now the quantifier is there is. So again, we are going to use the symbol there is this. So let me borrow this. So this become there is this x, where x stands for prime number. And that prime number is not odd, it's represented by p of x. That's what I've written here. Let p of x be x, which is not odd. So there is a prime number, which is there is this x, which is not odd, is p of x. Now, is this statement true or false?
True.
It's true. And what is your proof?
2 is a prime number, but it's not odd.
Exactly. 2 is a prime number because the prime numbers are numbers divisible by itself and 1. The first one is 2, the second one is 3, the next one is 5, the next one is 7. Then you come to 11, then goes to 13. See, all the other numbers apart from the first one are odd.
Odd numbers.
Exactly. So that's why this statement is actually true. 2 is the first one and it's not odd. Okay, so we have been able to know how to translate the English phrases into symbolic form. That's what we've done so far, and prove whether they are true or not. Now, the second part of this is now to be given a symbolic form like this, and now you are supposed to give me the words. So we'll take one or two examples and see. Now here, my p of x stands for x is an integer, and x squared is equal to 16. X is an integer, and x squared is equal to 16. So now, how will you put in words, there is this x p of x? Who can help us? There is this x p of x. We want this in words. Any volunteer? If you can't unmute. Yes, please.
There is an integer x.
So there is an integer. Okay. You can say that which satisfies such, you can say such that, or you can say which satisfies the equation x squared is equal to 2. Okay, like we did earlier, x squared is equal to 2. There's an integer such that x squared is equal to 16. I want the equation editor. Okay, there you are. So that integer x, we are saying that when we square it, When we square this integer, it should give me 16. It's equal to 16. Okay, so now is this statement true or false? Is there an integer that when you square, it will give you 16?
Yes, it's
Yes.
true.
Yes, it's true. Obviously, that is true. And what number is that? What number do you square and gives you 16?
4.
It's actually plus or minus 4. Okay, plus or negative 4. When you square these numbers, it will give you 16. Okay, that is a very good attempt at this. Let's take one more, then we would look at negatives. This time, my predicate statement is x is a real number, and then x squared is equal to 1. So again, who can try giving me, there's this xp of x in words?
Okay.
There is a real number.
Okay, so there is a real number. There's a real number such that
S
finish it
squared.
with x squared.
X squared plus 1 equals 0.
X squared plus 1 equals 0. Okay. X squared plus 1 equals 0. Okay. Let me finish writing the equation, then we can prove it. X squared plus 1 is equal to 0. Now, is this statement true or false? Is there a real number that when you square, you add 1, it will give you 0? Now, the best way to answer this is to solve for x. This equation, when you make x squared the subject, what do you get?
Negative 1.
X
Squared
squared
You get x squared
equal to
will be
negative
equal
1.
to
is equal to 1.
will be equal to plus or minus 1. Is it
Plus
not?
or minus 1.
Yes.
So you'll be getting to be equal to plus or minus square root of negative 1. Now, so on the calculator, can you find square root of negative 1? Sorry, it's not x squared, it should be x. We are finding square root. So x will be equal to plus or minus negative 1. Can you find square root of negative 1? Is it possible?
No.
No, sir.
No. It will give you math error. So
Yes.
what can we do? We will go to the calculator. Okay? We'll go to the calculator and then tell the calculator to use the equation mode to be able to find square root of negative 1. Okay, so let's do that. If you have a calculator with you, do it with me. If not, then I'm opening my calculator so that I can share. Okay, so I'm sharing the calculator as well. It should now show on your screen. Okay, so how do I go about this? I'm clearing my memory. So you go to mode, you go to equation 5, and then you choose quadratic, which is 3. Now look at this equation. This equation, x squared, the coefficient of x squared is 1. So 1 equal to. Now, you don't have a b term. You remember quadratic, you have ax squared plus bx plus c. There's no x term. So it means that my b is 0. Okay? And then my constant term is 1. My constant term is 1. So c is 1. Okay? Now, when I press equal to, x1 is equal to I. So from what I have here, I'm getting an equation that says that x1, I don't have time to use subscript. So x1 is equal to I. That's the first one I got. Then I got the next one. I'm getting x2 is equal to negative I. Okay, so now you must realize that these numbers I'm seeing on the screen here are not real numbers, because real numbers doesn't have things like I and minus I. So it means that the statement is false. Okay, so you must now identify what type of numbers are this. So because X is not real, but it is what? What type of numbers gives you I and minus I and stuff like that? What family of numbers are those? Anyone? You're not familiar with it. They are called complex numbers. So because the value of X that when you square and you add 1 will give you 0 will not be a real number. It will be a complex number. Okay, so that is why this equation is giving us values like this that are not real. Okay, so basically this is where we are with solving this. Okay, so what do we do when you are asked to negate statements? When you are asked to negate a predicate statement. Now, negation of a predicate statement, all you need to do is you first of all will negate the quantifier. When you negate a quantifier, then this is what happens. The universal quantifier, when you negate there exists, it will change to for all. And then when you negate for all, it changes to there exists. So these are the symbols that I have here. So for all becomes there exists, and there exists becomes for all. Then the next thing you do is that you negate the predicate statements. So if it is P of X, you come and negate P of X, become negative P of X. Now, I want to make sure you understand what I'm sharing. Let's go to the first example we saw today. All triangles have their sum of angles equal to 180. So now, if I take this equation right now, and I place it in a, when I even do that, it will not give me. So if I put this in a bracket, if I place this in a bracket like this, and then before it, I ask you to negate it. Where's my negation? So let's say that I ask you to negate this statement. So who can read the negation of this statement based on what I've just showed you? Negative for all X, T of X. How would this statement read? Solomon, can you try for us?
Sir, please, we are not seeing your screen. Oh,
Oh, really?
I'm seeing it. I'm
see
seeing
it.
it.
Yes,
We can see it.
Solo check your whether you're using a phone. Maybe swap to the left or right and see.
Let me try.
Okay. Okay, so who can help us? All triangles have their sum of angles equal to 180. Remember, the rule is if you are using or, it will change to there exists. Then the predicate statements given, you will negate it. So who can try this for us? What would be the negation of for all X, T of X?
There is this triangle.
There exists a triangle, okay? Then
Triangle.
what happens to equal to 180? What would it be? Now the sum of angles will be what?
Are not equal to 180.
Exactly. So
Are not.
when there are not, they are not equal to 180. So there is a triangle that its sum of angles are not, or there are triangles. When you take one, when you say there's this a triangle, then you say it's the sum of its angles is not equal to. But when you say there are triangles, then you say are not equal to. Okay, so whatever the English phrases, you are using the formula. Negative for all X, T of X becomes there is this X, negative T of X. Okay, what about this one? When I negate negative for all X, C of X, all cats have tails. When you negate it, what will it be?
They are cats without tails.
They are cats without tails. Good. So now let's restrict our questions to just mathematical equations or inequality. So if I give you a question like this, for all X, number one, for all X, this one. For all X, X squared is greater than or equal to X. What will be your answer? When you negate for all, what will it be?
There is
X.
So it becomes there exists. So we are going to use there's this x. So there's this x,
squared.
and what happens to x squared greater than?
S squared less than.
Less than or equal.
L
should
square
be-
less than or equal to.
Exactly, less than or equal to, you are right. So that should be x squared. This equation editor is giving me a problem. There's this x such that you have into bracket x squared. Well, we have x squared less than or equal to. Okay,
16.
so less than or equal to will give me the inequality like this, equal to x. And that will be your answer. Okay, so negation of greater than is not less than only, it's less than or equal to. Okay, what about the second one? There's this x, this time x squared is equal to 2. What will be my negation?
For all x.
For all x, sadly. So
Like
it becomes
that.
4. For
S
all
square.
x,
Yes.
so for all x, then into brackets,
That, yeah. S
x
square
squared.
is not equal to 2.
It's not equal to
Okay,
16.
good. Not equal to, actually not equal to 2. I am using an equation not equal to 2. So that is how we will solve problems like this. Okay, so basically that will be the end of predicates. The rest is to try your hands on the questions I gave. So if you go on the LMS, the questions that I asked under predicate statements are things like this. Group 1 to group 4, yours are translating from English to symbols or symbols to English. Okay, for example, here you've been given n of x represents x has visited North Mamprusi, where x stands for students in your school. So x is a student who has visited North Mamprusi. That is n of x. So you want you to translate there's this x, n of x into English. Okay, so who can try this one? There's this x, n of x. How will this read? X stands for a student, and n of x means that student has visited North Mamprusi. So how will you translate there's this x, n of x into words?
There is a student that has been to Mamprusi.
Okay, and then how will you translate number 4? There's this x, negative n of x.
There is a student that has not been to Mamprusi.
Okay, so question group 1, group 2. Group 2, yours also the same. You only have to remember the connective. This if and then. This is end. Okay, so you are all translating this into words. Now let's come to group 4. This time you are given words. You are translating it into symbols. So you must identify the quantifier and identify the predicates. Now in the question, you are told that P of x stands for this student. X is a student. Remember, they are saying the domain consists of all students. So P of x means that a student can speak Grushi. P of x means that a student knows the computer language Java. So who can translate this into symbols the other way around? There is a student at your school who can speak Grushi and who knows Java. First of all, what's the quantifier here? Essential or universal? The first word will tell you. What's the quantifier? Essential. Good. So we'll be using the E backwards. Okay. Then you identify the connective between them. The connective is end. So you know the symbol for end. Okay.
Yeah.
So you now will just identify which predicates are being used. So the predicate being used is speaking Grushi. Speaking Grushi is P of x. And knowing Java is Q of x. So as essential symbol, that is E backwards x into brackets. P of x, isn't it?
Yes,
and Q of x, exactly. Okay. Now, if you pay attention, you should be able to answer number 4. No student at your school can speak Grushi. or knows Java. What's the quantification? What's the quantifier here?
Negated, how do you call it? Existential.
Existential is 1. No. This one is saying no.
He said no.
So
Okay, let me.
negated P of X.
It's universal.
It's universal. It's here. Look at it. This is an universal quantifier. When they use no or none, it means universal. Okay. So here, negation of for all X, and then the speaking Gruchy is P of X. Knowing Java is Q of X. The connective is all. Okay. So group 1 to group 4, 4, 5, 6, you are translating. Then when we come to group 7, just 7 and 8, you will be asked to now define domain. So look at group 7. It says that translates in 2 ways. Each statement into logical connecting in logical expressions. And what you are supposed to do is that you identify the quantifier, identify the logical connectives. First, let the domain consist of students in your class. So this question, they haven't given you the predicates. Okay? They haven't given you the predicates. You must now identify your predicates. So you must identify the variable in the question. So let's take, for example, someone in your class can speak German. Okay? What's my variable here?
There exists.
Okay, no, there exists is quantifier. I know what you're talking about. That's the quantifier. But now the variable.
X.
Yes,
Your
X. In your class. Thank you. In your class. So it means that X can speak German. That is your variable. So
Yes,
you now will define X can speak German as, let's say, G of X or F
G
of
of
X.
X. Yes, sir.
Exactly. G of X. So it means that someone will become the existential quantifier, E backwards X, and then what? G of X.
Of X.
Okay. Please, are you following? Or I should go over?
Please
So,
go,
sir,
Yes, please.
please, with the I, would the domain be 2 or only 1?
When you say domain, because it says someone,
Yes.
yeah, they are talking about your whole class, but you're only picking one person in the class. Okay. So your domain is the students in your class, everybody. But because we say someone, we are picking existential, one person. So we are using there exists, or using the E backwards. Okay.
Yes.
So that gives you that. Okay, let's take the second one. Everyone in your class is friendly. Now, what is my quantifier?
Universal.
Universal. Exactly, everyone. So that is universal. Now, again, what is my variable?
Your class.
Your class. That will become that will be your X. And then what will be your predicate statement? Let's call it F of X. Your F of X will be what? F of X will read what? X is what?
X
class.
friendly.
X is friendly. Your class is X. So X is friendly. That becomes F of X. I'll be follow. So X is friendly. Now, everyone in your class becomes for all X.
All X.
Isn't it? For all X.
Yes.
And then into bracket. No, it's not EO. Everyone is the V, the A under the A upside down. Yes, the A upside down. That's
universal.
Universal. Then that that X is friendly becomes F of X. Okay, so this is what the second part is. Then the last group, yours is to choose domain. There are so many. I don't know how many groups you have, but the questions are designed to make you think a bit. Okay, the last group, what you are supposed to do is to define the domain that will make this statement to be true. And this one, please take your time and do if you're in group 8, group 9, and just enjoy the argument you come across. Can you define a domain? For example, let's take Ghana. Which part of Ghana can you make sure that everyone speaks Hausa? What domain? That will make this statement to be true.
Nothing.
You say everyone. Are you telling me everybody at the north can speak Hausa?
Yes. No.
So So these questions you must think a bit. Okay, think a little bit. I mean, a lot of students have tried. Somebody said maybe an Hausa speaking family.
Yeah, or Zongo community.
Yes, Zongo. I went to school at Zongo, Limau. I can't speak Hausa very well.
Bro, I
only
stay at
know.
Zongo. I can't speak Hausa.
Okay, so you must think a little bit. So define your domain realistically. Basically, that's what it's making you do. Please, all these are exercises to make you have an open mind. Okay. Some of the questions are very challenging. Can you give me a domain where every two people have the same first name? How is that possible? I don't even know. You give me a set of people or a set of domain where every two people you will pick, their first names will be the same. I have thought about it. I don't know what set I can pick. But these questions are from Kenneth Rosen, one of the books that we recommended. Okay, so
sir, is there a way
yeah.
that you can make the domain to, like, maybe for question II, you can say domain for which it is true, then you like prove your answer, and also domain for which it is false, or you have
Yes,
to stand on one thing, either true or
exactly.
false?
No, you have to give two types of domain. It can't be the same domain for it to be true and the same domain for it to be false. It might be two different domains. Yes. Okay. So
hello, sir.
Yes, I'm listening.
So, for example, if the answer is true, you have to give the domain, the reason why it is true, and then
Exactly.
if it's false, you have to give the reason why it is false.
Exactly. So how to make sure that everybody has the same first name? I don't know. Maybe you must be very imaginative. But for example, there is someone older than 22 years. A lot of students gave me a mature student. So that is okay. Or you can subtract 22 from 2000 and 2026. Okay. And all those who were born before that. So all those who were born before the year from 23 years and above. How do you understand what I'm saying? So you can say all mature students, it is true. And then you can also pick all, maybe which domain, all children that were born in 2000, they are in 2010, they are younger than 22 years. Okay, so these questions attributed to predicates are basically to help you understand the concept. Okay, so I will end with the methods of proof, and that I know is a bit technical, but I hope I can make you understand at least one of these techniques. Okay, so let me explain what methods of proofs are. Methods of proofs, what we are interested in is that when you are giving you a question, they say use direct method of proof, or use indirect or contrapositive method of proof, or use contradiction method of proof. Then you must be able to define, number one, define the method, and then two, correctly use the method. Okay, define the method and correctly use the method. Okay, so let's first of all understand what direct means. Direct means that when you are given an argument or you are given a statement, you assume the beginning of the statement, which we are calling the premise. You assume the beginning is true, and then you show the conclusion, which we are calling Q, show that the conclusion is also true. So that is direct method. Indirect or contrapositive method, you assume that the ending is false. It's because of Socrates, and then your MCQs, the quizzes on the LMS, those 15 MCQs. That's why I'm taking my time to explain this. So contrapositive, assume that the conclusion is false and also show that the beginning is also false. That's contrapositive. And then the last method, contradiction, you assume that the beginning is true, P is true, and Q is false. You assume two things. And then actually come and show that the conclusion was actually true. So it will reduce to the like direct, P is true and Q is true. So these are the methods. Now, then how do you use this? Yes, good afternoon. How do you use these methods to answer questions? Okay, so because this is a math class, I'll use mathematical things or use mathematical principles to test this concept. But and at the end of the day, you are supposed to remember the principle, not my maths examples, because in real life, in your area of expertise or where you are specializing, either information technology or computer systems administrator or computer science analyst or cybersecurity, the principles that are used in these areas of expertise, they may not necessarily be my maths. They may not be even numbers and odd numbers and stuff like that. They will ask you that, how do you prove using direct method that you can install, let's say, Visual Basic on an operating system, let's say on a Mac or on what are the types of even operating system that you have? So what I'm saying is that the concept of, yes, the concept of the method, the techniques in the method is what you need to remember. Because very soon you see that I'll start dialing numbers that it will start questioning some of the things you learned in KG and class 1, class 2. You see where I'm going with this. So don't be backed down by my examples. I know why I'm saying all this before I start. Okay, so let's pick a question. These are the questions that can help me explain the methods to you. Now, they are very simple things which we know already. Okay, so the first 6 examples or questions here, they are talking about even numbers and odd numbers. Now, if you take your time and look at the even numbers, first of all, can somebody define an even number for me? What is the definition of an even number?
It's a number that is divisible by 2.
Divisible by 2. Okay.
Without a remainder.
Thank you. And then an odd number?
That cannot be divisible by 2.
Either they say it cannot, or when you say it is divisible.
There is a remainder.
A remainder of what?
By 2 plus 1.
Okay.
A remainder of 1.
Thank you. So that is exactly what I need you to remember. This is the point I'm saying. I'm dialing numbers that are very basic. Okay, so when they give you a question like this, if m and n are odd integers, okay, then m times n is odd. Now remember that I said when you are giving the statement, you must identify the beginning of the statement. We are using if and then. So if means that the first statement in blue, the one I've colored blue, is my premise. The one that I've colored brown is my conclusion. So before you start, you must first of all identify your premise and your conclusion. And then the method that you are supposed to use, then you correctly use it. Okay, so let's now do a very quick review. The questions are here. You will have this material. It's also on the LMS. So let's do this and prove to ourselves that we know this. Now, if you take any 2 odd numbers in your head, and you multiply them, what type of number do you get?
Odd number.
You get an odd number. Thank you. That is true. If you pick an odd number and an even number and you multiply them, what do you get?
Even number.
Even number. Okay. So that is for number 1. That is for number 3. Okay. When you take an odd number and you square it, what do you get?
Odd.
You get odd. Okay. When you take an even number, okay, either you square it or multiply by another even number. What type of number do you get?
Even number.
Okay, so please, these are the things I am going to use to explain the methods to you. Okay, so I'm using mathematics. I'm using or I'm using numbers to explain this. So let's take the first one. Now, under normal condition, when a student sees a problem like number 1, okay, because he knows that 3 times 5 is 15 and it is true, 7 times 3 is 21 and it is true. When they see this question, they will say, oh, this question is simple. Just pick any 2 odd numbers and you multiply, and then you are done. Even though you are correct, mathematically, you are not correct. Why is it that you are not correct? Because the set of odd numbers or odd integers are not just 2 and 3, are not just 3 and 5, or 7 and 3, or 9 and 27. There are so many. It is an infinite set. So in maths, when you are proving that a set of infinite members there's a property there that satisfies them. You can just pick just one example and say that it satisfies all of them. Mathematically, it's not accepted. Rather, you must give a relationship that represents that family of numbers. And when you multiply, it will give you that family of numbers. I hope this goes well, because a lot of students say this, they say this is that's the only way that mathematically you can convince whoever said the question that this question, any odd number you pick and you multiply by any odd number, it gives you odd. But you can't pick just two specific numbers and do it. Okay, so based on the definition of an odd number, I've taken a few of them, 1, 3, 5, 7, up to 101. And you said these are numbers when divided by 2, there's a remainder of 1. So I want to be able to look at the way these numbers look like, and then if I can generate an equation that will represent them, so that I don't need to use the number 3, the number 5, the number 7 specifically. Now, if you take your time and look at 3 divided by 2 will give you one whole number, 1 over 2 in mixed fraction. If I take 5 and divide by 2, I'm going to get 2 whole number, 1 over 2, on and on and on and on. Okay, so those mixed fractions, I can write them as an equation. Let's start from the number 3. So 3 can be written as the number 2. You said when you divide by 2, it will go in there 1, and then there's a remainder of plus 1. This is what you said. 2, 1, 2, plus 1 will give you 3. When you take the number 5, 2 can divide 5. It will go in there 2 times, and the remainder will be 1. When I take 7, I know 2 can go into 7. That is 2 times 3 is 6, and the remainder is 1. Therefore, the number 1 can be actually 2 times the number 0, and then I'll add 1. If I take a very big number like 101, I know it will be 2 times 50, and then the remainder will be 1. Okay, so please, if I didn't do algorithm with you, but algorithm is simply to identify what is happening, and then those that are changing, you are going to represent them with a variable, and those that are remaining constant, you are going to leave them as constant. So in this number system that I am showing you, the number 2 remains the same for all the values of odd numbers. So if I say m is an odd number, n will be 2 times. Now, the number 0, the number 1, the number 2, the number 3, the number 4, the number 5, up to infinity. The number -1, -2, -3, -4, up to negative infinity. What type of numbers are those?
Real numbers.
They are not real. Real numbers has fractions, so they are not real numbers. The numbers I'm mentioning, there are no fractions there. So 0 to infinity, 0 to minus infinity. Whole numbers. Okay.
Whole numbers.
Okay, they are whole numbers. But when I bring negatives, we don't have negative values. They are not whole numbers. Whole numbers are actually positive values. So if the values they are integers. Thank you. Please, do we all agree? Where is Theo? Theo, do you agree from 0 to infinity, from 0 to negative infinity, whole numbers, that they are integers? Do you agree? Where are my ladies? Okay, so all I'm saying is that if this value like this, for example, happens to be -3, then this will be 2 times, what would that be? 2 times -4. -4, that will give you sorry, is it 2 times -4? 2 times -2, that will give you -4, plus 1 will give you -3. If this were to be -5, then I'll do 2 times another negative number. So the numbers that 2 is multiplying are integers. Integers are positive and negative whole numbers. Okay, so in the question, when we said if m is an odd integer and n is an odd integer, I will define m as 2k plus 1, where k is an integer, and then n can be 2 times h. Why am I using different numbers? Because let's say that my m is 3 and my n is 5. Therefore, it means that my k can be 1 and my k can be 2. So 2 times 1 plus 1 will give me 3. 2 times 2 plus 1 will give me 5. Please tell me you are following. This is where it is. This is the most the part that I was dreading that you understand. But if you understand this, the rest will just come as easy as that. Okay, so you must define the numbers as an equation, not just picking a value. So 2k plus 1 and then 2. Okay. So that is my premise. My premise is an odd number, 2 of them, and then my conclusion is multiply them. So now we must show that if I multiply 2k plus 1 times 2h plus 1, the answer I will get should be an odd number. Okay, so let's multiply 2k plus 1 all times 2h plus 1. Now remember what I want. I want an odd number. 2k times 2h will give me 4hk. Then 2k times 1 will give me 2k.
Okay.
And then 2h times 1 will give me 2h. And then all plus 1. 1 times 1 is 1. Okay, please remember what we want to. We want to show that this answer is an odd number. And what is the formula of an odd number? 2 times an integer plus 1. So this expression that I have here, is it possible that I can get 2 factored out times something plus 1? Yes. So you see that this part of the expression here, they all have a factor of 2 there. So if I take 2 out of those 3 things, I'll be left with 2 into brackets.
2hk
plus k plus
h.
h.
You close the bracket, all
plus
1. Good. Now, this is where the mathematicians will now show magic. It is not magic, it's still mathematics. What we are going to say is that I'm going to let the term in bracket 2hk plus k plus h, okay, to be equal to another variable, which is also another integer. Why? Because the numbers that I have in the brackets, they are also integers. If you take your time, if you multiply this 2 times 2 integers, multiply, plus another integer, plus another integer, the answer that I will get will be another integer. It will be a whole number. Okay, so I'm just going to let that term in bracket to be equal to, let's say, w, where w I've written here is that w is also another integer. Then this equation that I have here will simply can be written as 2 times w
plus 1.
Exactly. Okay.
Yes.
Okay, so when you are done, you can say that it means that m times n is also odd, which is what we said to prove. Okay, so all these questions that I've written here, all you need to do is to define the terms in terms of an equation. M and n are even numbers, so it means 2k times 2h. You know, even numbers are numbers divisible by 2 without a remainder. So instead of having 2k here, this one, you are going to define 2k and 2h and come and multiply them. I've done that. And you let w be equal to this. So it gives you 2 times w. Okay. When they give you number 3, even and odd, I have this is number 3 is an odd number, even and odd number. So what would that give us? Where's even and odd number? So this is an even number, this is an odd number. Then you multiply. When you multiply, you are going to get an equation that looks like this. Then you factor the term 2 out of it and let this be equal to another variable. Then you get an even number. So all these techniques that I'm showing you, they are virtually supposed to prove the various methods of proof. Okay, so like I normally tell those who want to solve questions like this, you only need to know one of the methods. If you know direct, indirect, you start from the conclusion and come and finish with the beginning. Contradiction, you will start from the beginning and then the ending, then come and show that the ending is actually true. Okay, so I want to end on this. There are quite a lot. Yes, please, Ruben.
Please. So if you use
Michael, go ahead.
Please, so if you use other methods, will you get the same answer?
I need to know what method you mean by another method.
In the types of methods there. instead of the direct method, and then you use the what's it called?
The indirect or contrapositive.
Yes.
Okay. Yes. So what? Yes, you can use any method. Now, maybe the way to answer you is for you to look at the questions we're looking at. So, for example, look at group 1. Group 1, your question was show that if n is an integer and n cubed plus 5 is odd. So this is the beginning of your statement. And then the conclusion is n is even. Now this one, you can't even use direct. Well, you can use direct. If you can use direct, it means that you must let this one become your p, and then let n cubed plus 5 become your q. Because direct method, you start from left to right. The beginning is true and the ending is true. But this one, they say use contrapositive, which is indirect method. So you see that the ending is starting the question. Okay, so my answer to you is that you can use any method, but the way the question is framed, if it is direct, you see that the beginning will be a normal question, and then the ending is the equation that is either squared or is cubed. If it's indirect, you see that the question will start with the number is cubed or is squared or is doing something, then the ending will be it's either even or it's either odd. So it's the way the questions are framed. So you can use any method to solve a problem, even if we specify, and you know how to rearrange the question, which one will be your beginning, which one will be your end, and then you follow through with it. Okay, so there are some questions there are some questions you see, they will not even tell you which method to use. They will just tell you that just choose an appropriate method to solve it. Okay, for example, prove that if m and n are integers and m times n is even, then m is even or n is even. You see, they didn't tell you which method. Okay, so it means that you will choose whichever method that works for you to be able to do that. Okay, any other question? Philip, were you going to ask a question? Okay, Angela, what about you? Do you have a question for me?
No, please, I'm fine.
Okay. So, if you go on to the LMS, we are here. This is where we are. Okay. This is where we are. So, I've given you your Socrative room name already. So, it will not show yet. But this is the PowerPoint I use. There are lecture videos on what I've gone through. Predicates, direct method, indirect, and then induction that we did last semester. Then the group question that we went through a few minutes ago is here. And then you have some 15 minutes multiple choice questions here that you can attempt. So far, I think there's only one person who has tried it. The questions are quite simple, but it's asking you to use the various methods of proof, contrapositive, logical equivalence, and all that. Okay, so take advantage of the platform and so that you can equip yourself more with the things that we have under the material. So gradually, we are sailing through. Next week, God willing, we'll be looking at set theory. Set theory will take us to things like equivalence relation, partial order set, Hasse diagram, and on and on and on and on. Okay, so you can use the LMS to be able to buttress some of the things that we've done today if some of them are not clear. Okay. Okay, so thank you for coming. I don't have any question online. And then I will recommend that you guys take care of yourself. The Accra, because of the rains, there are a lot of students who are stranded, even lecturers too, who are going through a lot. So please, within the time in which we are in, please stay safe. Stay safe so that we can all have you available when we need you. Okay. Enjoy the rest of the weekend. Okay.
Thank you, sir.
Okay, bye.
Thank you, sir.
Welcome.
Ruben.
Oh, yeah, there. And over here. Is it there? Is it Casario now there? Themselves were yeah there. Marie class. The last one. Right. Yeah. I'm sure. Is it there? They're going on. What's that? I said, "Can I be a sendo?"
Yeah, man, what's up? Oh, see you, see you. See you. What do you happen? Mm.
This is kind of that Sunday. You know, sure, say.
Ah, I tell you. You want you me if I say I will start, you go run away. Ah. Oh, if I say I go be very vibrant every time I go there. Charlie. Ah. Yeah. Yeah. We should I bring that argument. Hey, is it what it? Everything cool, my brother. This time everything be hard though. Hey, everything be hard. Hey, Charlie, it's like if you like I talk the like this thing they teach you right now. Hey, it be something no, Charlie. Everything it's like if you don't think and watch well and as you're watching you are thinking. Mm. Hey. Hey, Charlie. Charlie good to say that. Huh. See there, Zuguma. Watching over again and trying. You see how your man they teach for. If you see how your man they teach the programming, the C++. He dey run with us as if say we be like with somebody wey he do the course before but he need a recap like that kind of thing. They teach like somebody wey be beginner like we are beginners. Oh, Charlie. A thing if I teach one then you make we practice. Okay, what's the outcome? You see, yes. What's the outcome? Is everybody getting it? Before you go and to the next one, you just going. I finish. Now go next one. If next one conditional. Next one. It be like it's something simple to you are still asking question. So it make if you don't want if you want ask if you ask question, it think twice before you. They change your voice. They change your voice. Hey. I see. Oh, but I mean, I they watch the ones that they watch YouTube ones too. They follow. Oh, let's see, brothers. This week or be that what last week or be that what they watch they learn. Cause I want to make sure say I Bob we understand. Every evening be try to do something small. If I did work I make free I take my laptop I did learn something small. Okay. Code blocks I get code block I get visual studio. I for visual studio put there. I get a long time because now they do that the HTML, CSS and JavaScript. Oh, I don't know that whether that thing they will teach that thing now because I don't know whether they will teach those things. Mm. Yeah, I talk say I don't know say they go teach that we go do that HTML, the CSS and JavaScript languages for this for the whole course or this year. Oh really? Mm, I see. Oh, but if you be only C++, then what's the purpose of the this thing? Because it be the CSS where you go add that color. When you see somebody ask say if you want to make it redder, what you go do? If the CSS where you can add this color to it. Okay, now this prompt I want it to be in this it should be color like this. Yes, CSS where they do all those things. Then HTML they give them the sizes. If you want to make the thing come out boldly, you want to make it become bold, you want it to become big. HTML they do those things. Those things. You understand? So I don't know. C++. I see. Sorry. This is small more. I be the next one be six for the what's it called? The next one we will do be 6 o'clock. Oh, oh yeah. What? Who they teach? Let's see. Oh, probability. Okay. At least they will communication skills. Yeah. 3 o'clock. Now at least they be communication skills. No say that woman say no, it be tomorrow. It be tomorrow. Tomorrow 6 o'clock in the evening. Say 6 to 8.
That presentation will come on next week. Next week.
That be the this thing we videos we this girl they share for the page top.
Yeah, this one.
Hello. Hello.
Follow most of the courses, then most of the topics.
I beg who's online over here?
If we the topics make we go to on our research, then can present them on next week.
Oh, okay. I see.
I shall say in your group then.
Bernard, your microphone is on. Oh.
Charlie, before do what?
Sorry, not be easy. I do one. I do one.
Then do what then? About most of the things Charlie.
Then do what?
I shall say from level 200 they go there. We do more practicals. 300 say level 400.
Yeah, true. Say we make you develop that.
The last time they showed I go do the news. I go check give am.
They call you.
Yes, he called me.
Hey, for spenders there no. So go do give am.
Oh, I go do give am, but I be like nah. Obviously I will call them.
Oh, don't but hey, so he left. What will be to come do give am?
Mamprobi.
Hey, Mamobi.
I did Mamprobi.
Mamprobi, yeah. He left that side on.
I be that one.
Hey.
I did come spenders more times.
Oh, okay. If they come there, but if they come per post because of that, because I know say be something like BIA, it would need you to move all the way from that side.
That job, I got an app for campus. The legal man, we do that. It be like that. The person we do the thing, and now they won't spy am.
You want spy the now you know the one they talk. It be like he do for your phone too. If they feel am.
Watching this one, it moves. They give am that chance.
This one like this. If if the woman did a shop way, maybe she won't change way, she dey change her, and she dey watch. Oh, really? Oh, Charlie. We cover did that side too. We cover did that side too.
Come on, inside now, they know they go anywhere. Inside where this on the shop now, they don't go anywhere. They say I be them or the big girls who some of them cry and fit G them a body. Most of the Nigerians.
Hey.
And they G them a body. They don't wear pants. Then they go change them a body
For them.
She talk me. I say, oh, Charlie.
Hey, the guy who watch things. The guy who watch things. But so what did you G her from the top? You come out and you go you work. So you no go view again.
So if you change the verification code in that, so I use I change the verification code where I give a new one.
So now he be the main person.
Now he be the main.
I see.
So the nigga
So the nigga he now be the camera installer no.
We come to some job give them we is it then anything be I make because the shorty they don't know plenty people like that and these are people they don't know they don't get time they go search for workers they will come work with them. So it be like the nigga know the camera guy we do he use that nigga he use in phone we take connect to the shorty home. See.
I see.
The dollar use that nigga no phone connect the lady.
I see.
Connect them, that's why they get this one.
The guy see things. I just say every day if we come I go do playback. They see what happened that day. You go they do playback. Is it? So we sharp I see. The Kobanya one, no, if they talk, they hear the thing clear. Last time I go do playback, yes, they hear the voice well. Even of this, yeah, even the sound. When you check for the phone talk, you see, you can hear that they are talking, but you can't hear what they are saying because it's not coming out well. Yeah.
Camera, I don't know. It be like the time we had to go buy the camera. Oh, I don't get fake vision.
You no get sound camera for Hig Vision. Sound.
Get that one. You could pick up. That would that be the only
Oh, at first now it be clear. Be clear. You go hear if, but now I don't know why.
Anyway, you go give me the cables so maybe if I can close that man.
But I touch something. Make sharp. Now just Babasa they fight pass one customer before this. Now we won't hear what they talk. But now we should not hear what they talk. Well, they hear say they talk plenty, they shout for invoice stop. But we know they hear what they talk. But that's Babasa the Charlie. I don't know if boss for Saka, honestly.
That fair lady.
No, we don't fair. We should be fair. There, one she be like woman, be get plenty breasts.
You wanna?
No. She did there. Other than you go there, you see her for there. I'm sure say you talk Plaza on. Yeah, you talk. Yeah. Asantwa, Linda. Yeah, that girl, plenty things about her. I don't know.
I don't get eye.
Cause you don't get high.
Or if you
Okay, yeah, me I have a good time. But if people come interview her, no. If people come interview her, be something else. Oh. If they get job to her, then be something else. Yes.
Sometimes most of them be this one, then be I don't know the English, I forget the English word itself. Then be like something we or do money giddy, you know. Selling Sanya
Guys, sorry. I didn't know. Sorry.